Hello, in this lecture we will find the diameter of the semicircle. In the drawing we have a semicircle. The diameter of this semicircle is AB, and we want to find out the size of AB. We know that AD equals to 7 units, DC equals to 15 units, CB equals to 15 units, and we want to find out the diameter of this semicircle. That is to say, we want to find out the value of AB, or the size of AB. Size of AB. So first of all, we will connect together by a straight line points D and B. Actually, the peripheral angle ADB, this angle equals to 90 degrees. This angle equals to 90 degrees. It is a right angle. According to rule number 1, rule number 1 states that peripheral angle that rests or resting on the diameter of the circle equals to 90 degrees. I will read rule number 1 again. Rule 1 states that peripheral angle resting on the diameter of the circle equals to 90 degrees. So actually, ADL, angle ADL is a peripheral angle, and this angle rests on AB, that is the diameter of the circle. AB is the diameter of the circle, and peripheral angle ADB rests on AB, that is the diameter of the circle. Therefore, the size of angle ADB is 90 degrees according to rule number 1. Okay, so angle ADB equals to 90 degrees according to rule 1, because it rests on the diameter of the circle, that is AB, therefore it equals to 90 degrees. Okay. In the next step, In the next step, we will define the center of the semicircle as point O. This is point O, the center of this semicircle. And then we will join together points O and C by a straight line. Actually, OC called OC is the radius of the circle because it starts from the center of the circle and ends at point C, that is a point on the circle itself. Therefore, it is the radius of the circle. And also OB is the radius of the circle for the same reason. So we will mark OB as R, abbreviation for radius, and OC is also the radius of the circle, and we will join together points O and D by a straight line. Actually, chord OD is also the radius of the circle because it starts from the center of the circle, that is to say point O, and ends at point D, that is a point on the circle itself. Therefore, OD is the radius of the circle. I will mark it as R, abbreviation for radius. And in the next step, we will focus on triangle COD, the green triangle, triangle COD. And we will focus also on triangle OCB. So actually we will focus on the green triangle and the orange triangle. So in triangle OCD and triangle OCB, the green triangle, triangle OCD, and the orange triangle, triangle OCB. First of all, OD equals to OB. Both of those two chords, two line segments, are defined as the radius of the circle. Therefore, they are equal to each other. So OD equals to OB. Both of them equals to R, the radius of the circle. CD equals to CB equals to 15 units. It is given us in the question. Or DC equals to CB equals to 15 units. Okay. So in triangles OCD and triangle OCB, the green triangle and the orange triangle, OD equals to OB, both of them equal to the radius of the circle. OC equals to CB equals to 15 units. It is given us in the question as DC equals to CB, DC equals to CB equals to 15 units, DC equals to CB equals to 15 units. It is given us in the question. And OC equals to OC. OC is a common side. It belongs to the green triangle and it also belongs to the orange triangle. So OC equals to OC. Again, it is a common side. It belongs to both triangles. Common side. So actually we proved that all the sides of the green triangle are equal to all the sides of the orange triangle. Therefore, the green triangle is congruent to the orange triangle according to the rule side, side, side. If you prove that all the sides of one triangle are equal to all the sides of the other triangle, then those two triangles congruent to each other. So triangle OCD, the green triangle, is congruent to triangle OCB, the orange triangle, according to side, side, side rule, SSS rule. So from the fact that the green triangle is congruent to the orange triangle, we can deduce that angle OCD, this angle, equals to angle OCB, this angle, according to the rule that corresponding angles in congruent triangles are equal to each other. Okay, we can deduce that angle OCD is equal to angle OCB, and if we define angle OCD as alpha, then angle OCB that equals to angle OCD will be also equal to alpha. Okay? So, in the next step, we will focus on triangle DCB. Okay, so in triangle DCB, this triangle we know that side DC of triangle DCB equals to side CB of triangle DCB. Both of those two sides are equal to 15 units. Okay, DC equals to CB equals to 15 units. Again, in triangle DCB, side DC equals to side CB. Both of those two sides equals to 15 units in size. Therefore, angle BC, angle BDC, this angle BDC equals to angle DBC. Again, from the fact that those two sides are equal to each other, we can deduce that angle BCD equals to angle DBC according to rule number 2. Rule 2 states that in front of equal sides in the triangle there are equal angles. Again, in front of equal sides in the triangle there are equal angles. So I will read rule number 2 again. Rule number 2 states that in front of equal sides in the triangle there are equal angles. Okay, so actually in triangle DCB we have two sides that equal to each other, DC that are equal to each other, DC equals to BC. Therefore, in front of side DC we have angle DCB, DBC, this angle, and in front of side BC of triangle DCB we have angle BDC, this angle. And rule 2 states that in front of equal sides in the triangle there are equal angles. So those two angles that are located in front of equal sides, they are also equal to each other. That is to say, angle CDB equals to angle DBC. And if we define angle BDC as theta, then angle DBC will be also equal to theta because those two angles are equal to each other. Okay, so those two angles are equal to theta, and we also know that those two angles are also equal to each other. Both of those two angles are equal to alpha. The next step, we will define this point as point E. This point is defined as point E. Okay, again, this point is defined as point E. And then we will focus on triangle CDE and triangle CEB. So in triangles CDE and triangle CEB, okay, we'll focus on those two triangles. This is the green triangle and this is the orange triangle. On those two triangles, we know that side DC of the green triangle is equal to side BC of the orange triangle. Both of those two sides are equal to 15 units. DC equals to CB. Both of those two sides are equal to 15 units. And OE is a common side. It belongs to the green triangle, and OE also belongs to the orange triangle. So OE equals to OE. It is a common side. OE equals to OE. Common side. And we also know that those two angles are equal to each other. So angle alpha in the green triangle is equal to angle alpha in the orange triangle, or angle DCE equals to angle BCE. Angle DCE, angle DCE, this angle alpha equals to angle BCE. Okay, those two angles are equal to each other. Both of those two angles are equal to alpha. So we found out the two sides and the angle between them, two sides and the angle between them of the green triangle are equal to two sides and the angle between them of the orange triangle. Therefore, triangle CDE is congruent to triangle CEB, this triangle. According to the rule of side angle side, if you prove the two sides and the angle included of one triangle is equal to two sides and the angle included of the other triangle, then those two triangles congruent to each other. Okay, so according to side angle side rule. Again, triangle CDE is congruent to triangle CEB according to side angle side rule. Okay, So from the fact that those two triangles can go into each other, we can deduce that angle CEB, this angle, equals to angle CED, this angle. Okay? According to the rule that corresponding angles in congruent triangles are equal to each other. So angle CEB, this angle, is equal to angle CED again according to the rule that corresponding angles in congruent triangles are equal to each other. Okay? So we will define angle CEB as x. Angle CEB equals to x according to our definition. Okay, angle CEB equals to x, and because of the fact that those two angles are equal to each other, angle CED also will be equal to x. So angle CED also will be equal to x. Okay? Then we actually made the first construction that was the straight line that we draw from point D to point B. We made the first construction that was drawing a straight line between points D and B. So actually DB is a straight line according to our construction. Okay, DB is a straight line. DB is a straight line. Okay. Chord DB is a straight line. And we know that the sum of the angles at a certain point at one side of a straight line equals to 180 degrees. So this angle, that is actually angle DEB, equals to 180 degrees. Okay, angle DEB equals to 180 degrees because along a straight line at a certain point at one side of a straight line at a certain point, if we look only on this side, not on both sides but only on the upper side of the straight line DB, then the sum of the angles on the upper side of straight line DB will be equal to 180 degrees. That is to say, angle DEB equals to 180 degrees. Again, angle DEB equals to 180 degrees because of the fact that DB is a straight line according to our construction. Okay, but we know that the size of angle DEB is also equals to x plus x, that is to say it equals to 2x. Okay, angle DEB also equals to 2x. So angle DEB equals to 180 degrees from one side because it is a straight line, but from the other side angle DEB equals to 2x. Okay, again, angle DEB from one side it equals to 180 degrees, and from the other side it equals to 2x. Okay, angle DEB equals to 180 degrees from one side because this angle equals to 180 degrees, and from the other side angle DEB also equals to x plus x, that is 2x. So from this equality we can deduce that 2x equals to 180 degrees, x equals to 180 degrees, and here we can divide this equality by 2 and we will get that x equals to 90 degrees. Angle x equals to 90 degrees. Angle x equals to 90 degrees. So here x is a right angle, it equals to 90 degrees, and here also x is a right angle, it equals to 90 degrees. So here we can substitute x by 90 degrees. So angle DEC is a right angle, and also angle CEB is a right angle. Okay, so those two angles are right angles. And we also know that OC is the radius of the circle because it starts from the center of the circle, that is to say from point O, and ends at point C, that is a point on the circle itself. So OC is the radius of the circle. OC, chord OC is the radius of the circle. Therefore, OC is the radius of the circle, is a straight line. OC is a straight line. OC is a straight line, so therefore, again, if we focus on point E and at the left side of this straight line OC, the sum of the angles at point E and in the left side of the straight line OC will be equal to 180 degrees. Actually, this angle equals to 180 degrees. Okay, this angle equals to 180 degrees because of the fact that at a certain point and at one side of a straight line, the sum of the angles equals to 180 degrees. So actually we can say that this angle CEB, that is a right angle that equals to 90 degrees, plus angle BEO is equal to 180 degrees, again because of the fact that along a straight line, if we focus at a certain point and only on one side of that straight line, the sum of the angles equals to 180 degrees. So this angle that equals to 90 degrees plus this angle equals to 180 degrees. 90 degrees plus angle BEO equals to 180 degrees. So if we subtract 90 degrees from this equality, we will get that angle BEO equals to 90 degrees. Angle BEO equals to 90 degrees. Okay, angle BEO, this angle equal to 90 degrees, equals to 90 degrees. Okay, so actually this is a right angle. So around point E, this is point E, around point E we have three right angles. The sum of those three right angles is equal to 270 degrees. So I will write it down. The sum of three angles around point E is equal to 270 degrees. This is point E, and around point E we have three right angles that the total sum of them is 270 degrees. And we also have a rule that states that the sum of the angles around any point is equal to 360 degrees. Okay, we have rule. I call it rule number 3. Rule number 3 states that the sum of the angles around any point is equal to 360 degrees. The sum of the angles around any point is equal to 360 degrees. I'll read rule number 3 again. Rule number 3 states that the sum of the angles around any point is equal to 360 degrees, and especially the sum of the angles around this point E, must be equal to 360 degrees according to rule number 3. Okay, so the sum of the angles around point E equals to 360 degrees. The sum of the angles around point E is equal to 360 degrees. Okay, the sum of the angles around this point is equal to 360 degrees. Okay, so point E, we have point E. We know that the sum of the angles around point E is 360 degrees. And we have already found out that angle around point E, we have 3 right angles, that the sum of them is equal to 270 degrees. So the fourth angle must complete the sum of the angles around point E to 360 degrees. Okay, so 270 degrees plus the size of the fourth angle must be equal to 360 degrees. Okay? We will define the angle, the fourth angle that is missing, as angle X. Okay, angle X equals to the angle that is missing. That is to say, angle X is angle OED. This angle OED, is the angle that is missing. So angle X equals to angle OED. So 270 degrees, that is the sum of the 3 right angles, plus and the value of angle X, that is actually angle DEOED. So 270 degrees plus the size of angle X equals to 360 degrees. we can subtract 270 degrees from this equality, and we will get that x equals to 90 degrees. X equals to 90 degrees, and x equals to angle OED according to our definition. So angle OED, this angle is also a right angle. So we actually found out that around point E we have three right angles, that the total sum of them is 360 degrees. Okay, so in the next step we will focus on two triangles, on the big triangle, triangle ADB, and on the small triangle, triangle OEB. I will draw them again. So we have triangle ADB, we have triangle ADB, so this is triangle ADB. We know that angle ADB is a right angle, it equals to 90 degrees, and we also have inside the big triangle, small triangle, triangle OED. We have the small triangle, and angle OED is a right angle, it equals to 90 degrees. So we will focus on those two triangles that are actually right triangles. So we'll focus on triangle, the big triangle, triangle ADB. And triangle OEB. Okay, we will focus on triangles ADB and triangle OEB. The big triangle, triangle ADB, and the small triangle, triangle OEB. We know that angle ADB equals to angle OEB. Both of those two angles are right angles, so they are equal to each other. Equals to 90 degrees. So angle ADB equals to angle OEB both those two angles are equal to 90 degrees. Okay, angle ADB equals to angle OEB. Both of those two angles are right angles, they are equal to 90 degrees. We know also that angle B is a common angle, it belongs to both triangles, so angle B equals to angle B. And the third angle, angle DAB, or angle DAB equals to angle EOB. Again, angle DAB is equal to angle EOB according to the third angle theorem. Third angle theorem or rule or actually third angle rule states that if you have two triangles that are equal to each other by two angles, then the third pair of angles must be equal in those triangles. Okay, so if two triangles has two angles that are congruent to each other, then the third pair of angles must be equal in those triangles. So according to the third angle theorem, angle DAB equals to angle EOB. Okay, so we actually proved the three angles of the big triangle ADB are equal to three angles of the small triangle OEB. Therefore, we actually proved that those two triangles are similar to each other according to angle rule. Okay, so I write it down. According to angle rule, the big triangle ADB is similar to the small triangle EOB. Again, according to angle rule, triangle ADB is similar to triangle EOB, angle rule states that if you have two triangles that are equal to each other in three angles, then those two triangles are similar to each other. So from the fact that the big triangle ADB is similar to triangle OEB, the following relationship exists between the sides of those two similar triangles. Actually, OB over AB, OB the side of the small triangle over AB the side of the big triangle equals to OE over AD. Okay, the following relationship exists between the sides of those two similar triangles. OB over AB equals to OE over AD. OB over AB equals to OE over AD. Okay, but what is the value of OB? OB is the radius of the circle, equal to the radius of the circle. So OB is actually the radius. It is R. What is the value? We also know that OA is also the radius of the circle, because it starts from the center of the circle and ends at point A, that is a point on the circle itself. Therefore, OA is also the radius of the circle. Okay, and what is the value of AB? AB equals to R plus R. It is the diameter of the circle. AB equals to 2R. Okay, 2R equals to OE over AD. What is the value of AD? AD equals to 7 units. It is given us in the question. So in total we got that R over 2R equals to OE over 7. Here we have R over R is 1, so R is cancelled. So in total what is left here is that 1 over 2 equals to OE over 7. 1 over 2 equals to OE over 7. Okay, 1 over 2 equals to OE over 7. Here we will multiply this equality by 7 and we will get that OE equals to 7 over 2 units. So we found out that OE equals to 7 over 2 units. Okay, and what is the value of EC? The value of EC equals to OC over OE. Again, OC over OE equals to the value of EC. So EC equals to OC minus OE. Okay, EC equals to OC minus OE. We have already found out that OE, here OE equals to 7/2 units, okay? OE equals to 7/2 units, so I write it here that OE equals to 7/2 units. OE equals to 7/2 units. And EC equals to OC minus OE. We know that OE is 7/2 units. And OC, what is the value of OC? OC is the radius of the circle because it starts from the center of the circle and ends at point E. That is the point on the circle itself. Therefore, OC is the radius of the circle. So in total, we found out that EC that equals to OC minus OE, it actually equals to R minus 7/2 because OC is the radius and OE equals to 7/2 units. So EC equals to R minus 7/2. Again, EC equals to R minus 7/2 units. In the next step, we will focus on two right triangles. Triangle ECB is a right triangle because of the fact that angle CEB is a right angle, and also triangle DEB is a right triangle because angle DEB is a right angle. This is a right angle and this is a right angle, so therefore we have here two right triangles. Triangle ECB is a right triangle and triangle EOB is also a right triangle. So we can implement the Pythagorean theorem on the two right triangles by the statements that EB squared equals to EB squared. Okay, we'll use this quantity that EB squared equals to EB squared. And the reason that we are using this equality is because of the fact that EB is a common side. EB belongs to the right triangle, triangle ECB, and it also belongs to the right triangle, triangle OEB. Okay, so we can implement the Pythagorean theorem twice on side EB of those two right triangles because EB belongs to both right triangles. So EB squared equals to EB squared. And EB, well, the statement EB squared equals to EB squared relates to the two different right triangles. In the first EB squared, we have to relate to this triangle, the right triangle, triangle EBC, and in this state, EB squared equals to CB squared minus EC squared. Again, in the right triangle, triangle ECB, EB squared equals to CB squared minus EC squared because CB is the hypotenuse. And what is the value of EB squared in this right triangle? In the right triangle, triangle EDB, the value of EB squared equals to R squared minus OE squared. of OB square minus OE square. Okay, so in total we arrive to this equality. CB square minus AC square equals to OB square minus OE square. But what is the value of CB? CB equals to 15 units, so CB square is 15 square, and 15 square is 225 minus EC square. We have already found out that EC equals to R minus 7 over 2, so EC square will be equal to R minus 7 over 2 square. Equals to EB square. And what is the value of OB? OB is the radius of the circle, so OB square is R square. And what is the value of OE? OE equals to 7 over 2. So OE square will be equal to 7 over 2 square, that is 49 over 4. So in total we got this equality 225 minus R minus 7 over 2 square equals to R square minus 49 over 4. So here we will calculate the value of R minus 7 over 2 square. In total we will get that 225 minus R minus 7 over 2 square equals to R square plus 7 over 2 square is 49 over 4 minus 2 times R times 7 over 2 equals to R square minus 49 over 4. So in total we got that 225 minus R square plus 49 over 4 minus 2R square minus, here we have 2 in the numerator of this expression and we have 2 in the denominator of this expression, so we can cancel 2. In total we got here 7R. Okay, so here we will open the bracket and we will get that 225 minus R square minus 49 over 4 plus 7R equals to R square minus 49 over 4. So here we have minus 49 over 4 in this side of the equation of the equality, and we have minus 49 over 4 on the other side of the equation, so we can cancel minus 49 over 4 because we have them on both sides of the equation. Here we will add to this equality R square and we will get that 225 plus 7R equals to 2 r squared. So here we will subtract 7r and 225 from this equality, and we will get the quadratic equation, the 2 times r squared minus 7r minus 225 equals to 0. So we got this quadratic equation, and the coefficients of this quadratic equation are capital A equals to 2, B, capital B equals to minus 7, and capital C, it is the coefficient of this quadratic equation, equals to minus 225. Okay? So we found the coefficients of our quadratic equation, and actually the general formula of a quadratic equation is ax squared plus bx plus c equals to 0. That is the general formula for a quadratic equation, ax squared plus bx plus c equals to 0. And the solution to this quadratic equation is actually, first of all, x is the variable of this quadratic equation, and capital A, capital B, and capital C are the coefficients of this quadratic equation. So the solution to this quadratic equation means that the value of the variable x can be found according to this formula. X equals to minus b plus minus root of b squared minus 4 times a times c over 2 times a. Okay? So that is the solution for a quadratic equation, when x is the variable of the quadratic equation, and capital A, capital B, and capital C are the coefficients of this quadratic equation. We have our quadratic equation that states that 2r squared minus 7r minus 225 equals to 0. Okay? So here the variable of the quadratic equation is r. So here x equals to r. So we'll substitute x by r, and we have already found out that b equals to minus 7, so minus b is minus minus 7, that is plus 7, plus minus root of b squared, b is minus 7, so b squared is minus 7 squared is 49, minus 4 times a is 2, 4 times a is minus 8, times c is minus 225, over 2a, a equals to 2, so 2 times a is 2 times 2 is 4, so in total we got this the solution for the quadratic equation, So here 49 minus 8 minus 225 is 1800. Okay, so R equals to 7 plus minus root of 49 plus 1800 over 4. Okay, so we found out that R equals to 7 plus minus 49 plus 1800, 49 plus 1800, 1849. I will write it down. So R equals to 7 plus minus 1849, and the root of 1849 is 43, so R equals to 7 plus minus 43 over 4. Okay, so we got this, the solution for the quadratic equation, or the roots of the quadratic equation. So R equals, we have the first possibility that R equals to 7 plus 43 is 50. 50 over 4 is 12.5. So R equals to 12.5. That is one possibility. And we have other solution. R also can be 7 minus 43 over 4. Okay, R also can be equal to 7 minus 43 over 4. 7 minus 43 is minus 36 over 4 is minus 9. So we got a solution that R equals to minus 9, but this solution is an incorrect solution, because R must be a positive number. R is greater than 0, and we got negative R, so it is incorrect answer, because the radius of a circle or a semicircle must be a positive number, so this possibility is incorrect, and the only possibility that we left for the value of R is that R equals to 12.5 units. So we have to find out the diameter AB. AB is actually equals to 2 times the radius. It equals to R plus R. That is to say, AB equals to 2R. And we have already found out that R equals to 12.5, so 2 times 12.5 is actually 25, or AB, it also equals to D, it also equals to 2R, equals to 25 units. Okay, AB equals to 25 units. That is to say, the diameter of the semicircle D, that equals to 2R, equals to 25 units. Okay, the diameter of the circle equals to 25 units. Okay, so in the next step I will summarize the lecture. Actually, we wanted to find out the diameter of this semicircle. We know that BC equals to 15 units, DC equals to 15 units, and AD equals to 7 units. and AB is the diameter of the semicircle, and we want to find out the diameter of this semicircle. Okay, first of all, we made a construction. We connected points B and D by a straight line, and the angle ADB, that is a peripheral angle, it is actually equals to 90 degrees according to the rule number 1, that states that peripheral angle resting on the diameter of the circle equals to 90 degrees. So actually angle ADB is the peripheral angle that rests on AB, that is the diameter of the circle, therefore it equals to 90 degrees. Okay, so angle ADB is the right angle, it equals to 90 degrees according to rule number 1. Okay, and then we defined the center of the circle as point O, and then we connected together points O and C by a straight line, and we also connected together points O and D by a straight line. And then we compared between the green triangle to the orange triangle. We focus on those two triangles. We know that OD equals to OB equals to R. OD is the radius of the circle because it starts from the center of the circle and ends at point E, that is the point of the circle itself. Therefore, OD is the radius of the circle, and OB is also the radius of the circle, from the same reason, because it starts from the center of the circle, that is to say from point O, and ends at point B, this is the point of the circle itself. So actually OD equals to OB equals to R, OD equals to R, and OB equals also to R, so they are equal to each other. And also DC equals to BC equals to 15 units, DC equals to BC equals to 15 units, it is given us in the question. And OC equals to OC, it is a common side, it belongs both to the orange triangle and also to the green triangle. Therefore, OC is a common side. So we actually proved the three sides of the green triangle are equal to three sides of the orange triangle. Therefore, we proved that those two triangles can go into each other according to side rule. Okay. Then we focused on triangle DCB. On this triangle, we know that BC equals to DC equals to 15 units. It is given us the question. From this, the fact that DC equals to BC, we can deduce that those two angles are also equal to each other, according to rule number 2, that in front of equal sides in the triangle there are equal angles. Okay. So therefore, those two angles that are located in front of equal sides are also those two angles that are located in front of equal sides, they are also equal to each other. So both those two angles are defined as alpha, as theta. Okay. Okay, so angle BCE equals to angle angle BEC equals to angle CBD equals to angle CDB. Angle CDB equals to angle CBD. Okay. According to rule number 2, those two angles are equal to each other. We define one of them as theta, so the other one also must be equal to theta. Then we focus on those two triangles, triangles DCE and triangle CEB. On those two triangles, DC equals to BC equals to 15 units, and also OE equals to OE. Again, DC equals to BC, both of those two sides are equal to 15 units, and OC equals to OC. Okay, again, OC equals to OC. OC is a common side, it belongs to both triangles, to the triangle CDE and triangle CBE. So OE equals to OE. OE, it is OE actually because this is point E. So OE equals to OE. And those two angles are also equal to each other. So we found that two sides and the angle between them are equal to two sides and the angle between them. We found that two sides and the angle between them on the right triangle are equal to two sides and the angle between them on the orange triangle. Therefore, we can deduce that triangle CDE is congruent to triangle CEB. Okay? Those two triangles are congruent to each other according to side angle side rule. Okay, so angle CDE and triangle CDE is congruent to triangle CEB according to side angle side rule. Okay, so from the fact that those two triangles congruent to each other, we can deduce that angle BEC is equal to angle CED. Those two angles are equal to each other. Okay, again, from the fact that those two triangles congruent to each other, we can deduce that angle CEB equals to angle CED. According to the rule that states that corresponding angles in congruent triangles are equal to each other. So for that reason, those two angles are equal to each other. We defined one of them x, so the other one also must be equal to x. And we know that BD is a straight line because we draw a straight line between points P and D. Therefore, BD is a straight line, and we know that the sum of the angles along a straight line at a certain point equals to 180 degrees. So from one side, angle DEP equals to 180 degrees, but from the other side, angle DEE, angle DEB equals to x plus x, because it is x and this is also x. So from the other side, angle DEB equals to 2x. Okay? So from this equality, we can deduce that 2x equals to 180 degrees, and we divided this equality by 2, and we got that x equals to 90 degrees. So angle CED equals to 90 degrees, and angle CEB also equals to 90 degrees. Okay, those two angles are right angles. Okay, and we know that OC is the radius of the circle, OC is the radius of the circle, and therefore it is a straight line. And again, along a straight line, if we focus on one point along along the straight line, at a certain point, the sum of the angles in one side of the straight line OC, the sum of the angles is equal to 180 degrees. Okay, that is from one side. The sum of the angles from one side of the triangle, from one side of the straight line, if we focus on certain point, that is to say, if we focus on point E, the sum of the angles of a triangle okay, so OC is a straight line, and the sum of the angles at a certain point at one side. For example, here we looking on the sum of the angles of around point E on the left side of the straight line. It must be equal to 180 degrees. So this angle is equal to 90 degrees plus angle OEB must be equal to 180 degrees. Again, 90 degrees plus angle BEO must be equal to 180 degrees, because of the fact that if we look at any certain point, the sum of the angles along the straight line at a certain point must be equal to 180 degrees. Okay, so here we subtracted 90 degrees from this equality, and we got that angle BEO equals to 90 degrees. So angle BEO is a right angle. So we know that the sum of three angles around point E equals to 270 degrees, because 90 degrees 3 is 270 degrees, and we have a rule number 3, that states that the sum of the angles around any point is equal to 360 degrees. Okay? So, and especially the sum of the angles around point E equals to 360 degrees according to rule number 3. So we've already found out that the sum of the angles, the sum of the three angles around point E equals to 270 degrees. Okay? So we have three angles that the sum of them is 270 degrees. So if we add to the three angles the fourth angle, then the sum of those four angles must be equal to 360 degrees. So if we define the size of the fourth angle as x, then we will have the equality that states that 270 degrees plus x, that is actually the sum of the four angles around point E, must be equal to 360 degrees. Then here we can subtract 270 degrees from this equality, and we'll get that x equals to 90 degrees. Okay, x equals to 90 degrees. So we actually found out that all the angles around point E are right angles. All the four angles around point E are right angles. Okay? Then we actually focused on two triangles, triangle ADB and the small triangle OEB. And in those two triangles, angle ADB equals to angle OEB. Those two angles are right angles, therefore they are equal to each other, and they also have a common angle, that angle B belongs to those both triangles. So therefore angle B equals to angle B, and the third angle, angle DAB, also equals to angle EOB, according to the third angle rule. It states that if you have two angles that are equal to each other at two triangles, then if you have two angles that are equal to each other at two triangles, then the third pair must be also equal. Okay, if two angles in triangle 1 are equal to two angles of triangle 2, then the third pair of angles must also be equal. That is to say, the third angle of the first triangle must be also equal to the third angle of the second triangle. So this is the third rule. Okay, so we actually found out that all the angles of triangle ADB are equal to all the angles of triangle OEB. Therefore, those two triangles are similar triangles. Okay, according to angle rule. Okay, triangle ADB is similar to triangle EOB because three angles of triangle ADB are equal to three angles of triangle EOB. Therefore, the following equality exists between those two similar triangles, and actually OB over AB, OB over AB equals to OE over AD. Okay, OB over AB equals to OE over AD, but we know that OB is the radius of the circle, and AB equals to 2 times the radius of the circle because it is the diameter of the circle. So OB equals to R and AB equals to 2R, and we also know that AD equals to 7 units. So from this equality we found that OE equals to 7 over 2, and then EC equals to OC minus OE. Again, EC equals to OC minus OE. That is to say, EC equals to OC, that is R, minus OE, that is 7 over 2. So EC equals to R minus 7 over 2. Then we have here two right triangles, the orange triangles. We have two right triangles, two right orange triangles. Triangle BEC is a right triangle because angle CEB is a right angle, and triangle BEO is also a right triangle because it has this angle that is angle that equals to 90 degrees. Okay, so, and also you should remember that AB belongs to both right triangles, to the right triangle, triangle EBO, and to the other right triangle, triangle VEC. Okay, therefore we can implement the Pythagorean theorem twice on side EB. One time we relate to the right triangle, triangle OEB, and the other time we will relate to the right triangle, triangle VEC. Okay, so we have the equality that states that EB square equals to EB square. EB square equals, if you relate to this, to this right triangle, EB square equals to CB square minus EC square. Okay, EB square equals to CB square minus EC square. And then EB square equals to EB square. So here EB square, it belongs to this triangle, this right triangle, triangle OEB. So EB square here will be equal to OB square minus OE square. EB square equals to OB square minus OE square. But we know that OB is the radius of the circle, and OE equals to 7 over 2, so E square will be equal to 49 over 4, and CB is equals to 15 degrees, so CB square is 15 squared, that is 225, and CE equals to, and CE equals to R minus 7 over 2. CE equals to R minus 7 over 2. So CE square is R minus 7 over 2 square. So we solve this equality and we got to a quadratic equation. And then we solve this quadratic equation according to the special formula for the value of the variable in a quadratic equation as a special formula, and we use the special formula in order to solve our quadratic equation. Okay, the special formula states that x equals to minus b plus minus root of b squared minus 4 times ac. Okay, when capital A, capital B, and capital C are the coefficient, they are the coefficients of this quadratic equation, and x is the variable of this quadratic equation when the general quadratic equation is ax squared plus bx plus c equals to 0. So we found out the values of capital A, capital B, and capital C, and x in our quadratic equation is actually r. The variable in our quadratic equation is the radius of the semicircle. So we have all the data that we need to solve this quadratic equation. We solve this quadratic equation and we arrive to two results. The first result is r equals to 12.5 units, and the second result was that r equals to 9 units. But because of the fact that r is the radius, it must be a positive number. Therefore, r equals to minus 9 is incorrect answer, and so we left only with one possibility, that r equals to 12.5 units, and the diameter of the circle is actually equals to 2 times the radius of the circle. So if r equals to 12.5 units, then 2 times 12.5 units is 25 units. So AB, that is the diameter, AB, that is the diameter of this semicircle, and it also equals to 2 times the radius of the circle, equals to 25 units in its size. So the value of the diameter of this semicircle is 25 units, or 2 times the radius of the circle is 25 units. Okay, thank you very much.